What if everything you thought you knew about the future of the automobile industry was wrong? What if electric vehicles, EVs, the supposed saviors of the planet, were about to be dethroned by a revolutionary new technology? Toyota, the automotive giant that has consistently defied expectations, has just made a shocking announcement that could turn the entire EV industry on its head. While the world races toward an all-electric future, Toyota has been quietly perfecting a game-changing innovation that could render EVs obsolete. The company's CEO has boldly declared, "Our new engine will destroy the entire EV industry." But what is this groundbreaking technology, and how could it possibly disrupt the EV revolution? Let's dive deep into Toyota's latest move and uncover the science, strategy, and potential impact of this seismic shift in the automotive world. For years, the automotive industry has been hurtling toward an electric future. Governments, automakers, and environmentalists have all rallied behind EVs as the ultimate solution to reducing carbon emissions and combating climate change. Tesla, Rivian, and other EV pioneers have dominated headlines, while traditional automakers have scrambled to electrify their fleets. But Toyota, one of the most influential players in the industry, has always marched to the beat of its own drum. While others have gone all in on EVs, Toyota has remained skeptical, advocating for a more diversified approach that includes hybrids, hydrogen fuel cells, and even next-generation combustion engines. Now, the company has unveiled its boldest move yet, a revolutionary new engine that could upend the entire EV industry. But before we explore this groundbreaking innovation, let's take a step back and understand how Toyota became the automotive giant it is today. Toyota's legacy. How it became a giant. Toyota's journey to automotive supremacy is a tale of innovation, resilience, and strategic foresight. Founded in 1937 by Kiichiro Toyota, the company emerged from the Toyota Automatic Loom Works, a business established by his father, Sakichi Toyoda. Sakichi was an inventor who revolutionized the textile industry with his creation of the world's first automatic loom in 1924. This invention not only improved efficiency, but also embodied the principle of jidoka, the concept that machines should stop automatically when a problem occurs. This philosophy would later become a cornerstone of Toyota's manufacturing process. The transition from textiles to automobiles was fueled by Kiichiro's vision and the capital obtained from selling the loom patent to a British company in 1929. Recognizing the potential of the automotive industry, Kiichiro established an automotive division within his father's company, leading to the production of Toyota's first passenger car, the Model AA, in 1936. This marked the official birth of the Toyota Motor Company in 1937. In the aftermath of World War II, Japan faced severe economic challenges. Toyota, like many other companies, struggled to survive. It was during this period that Toyota's leaders, including Taiichi Ohno and Eiji Toyoda, sought innovative ways to improve efficiency and reduce waste. They developed the Toyota Production System, DIPS, a manufacturing methodology that emphasized just-in-time production and jidoka. This system aimed to produce only what was needed, when it was needed, and in the exact amount required, thereby minimizing waste and optimizing efficiency. The TPS also introduced the concept of Kaizen, or continuous improvement, encouraging every employee to actively participate in the process of identifying and eliminating inefficiencies. This culture of constant enhancement became deeply ingrained in Toyota's operations, leading to significant improvements in quality and productivity. Toyota's commitment to innovation was further demonstrated with the introduction of key models that would define its global presence. The Toyota Crown, launched in 1955, was the company's first mass-produced passenger car and played a key role in establishing Toyota's reputation in the automotive market. Following this, the Toyota Corolla was introduced in 1966. Designed to meet the needs of a wide range of consumers, the Corolla became renowned for its reliability and affordability. Its popularity soared, and it has since become one of the best-selling cars worldwide, symbolizing Toyota's commitment to quality and customer satisfaction. By the 1980s, Toyota had solidified its position as a global automotive leader. The company's emphasis on reliability, efficiency, and continuous improvement resonated with consumers worldwide. The principles embedded in the Toyota production system not only enhanced manufacturing processes, but also fostered a corporate culture that prioritized quality and innovation. This foundation enabled Toyota to navigate challenges, adapt to changing market dynamics, and consistently deliver vehicles that met and exceeded customer expectations. The evolution of Toyota's engines, a legacy of innovation. From its early endeavors to the iconic power plants that have become legends in the automotive world, Toyota's engines have continually evolved to meet the demands of drivers and the challenges of modern engineering. In the 1930s, Toyota embarked on its automotive journey with the development of the Type A engine. This 3.4-liter inline-six engine was Toyota's first foray into engine manufacturing, laying the foundation for future advancements. The Type A engine powered the Model AA sedan, Toyota's first passenger car, marking a significant milestone in the company's history. Following the success of the Type A, Toyota introduced the R-Series engines in the 1950s. These engines, particularly the 2.0-liter 3R and 1.5-liter 2R, were known for their durability and simplicity. They became the backbone of Toyota's lineup, powering models like the Toyota Crown and the Land Cruiser. The R-Series engines were produced for several decades, with various iterations and improvements, solidifying Toyota's reputation for reliability. As the company expanded its global presence, the demand for high-performance engines grew. This led to the development of several iconic power plants that have since gained legendary status among enthusiasts and racers alike. Introduced in the early 1990s, the 1JZ-GTE and 2JZ-GTE engines are perhaps the most celebrated in Toyota's history. The 1JZ-GTE, a 2.5-liter twin turbocharged inline-six, debuted in 1990. It featured a robust cast iron block and was known for its high revving nature and smooth power delivery. With an output of around 280 horsepower, it powered models like the Toyota Chaser, Mark II, and Soarer, offering a blend of performance and luxury. The 2JZ-GTE, a 3.0-liter twin turbocharged inline-six, followed in 1991. This engine gained international acclaim for its strength and tuning potential. With a factory output of 280 horsepower, it powered the Toyota Supra Mk4, among other models. The 2JZ-GTE's over-engineered components, such as its forged internals and iron block, allowed tuners to extract immense power, with some builds reaching over 1,000 horsepower. Its durability and performance have made it a legend in the automotive community. Then there's the 4AGE engine. Introduced in the early 1980s, it is a 1.6-liter inline-four that became renowned for its performance and versatility. Featuring a dual overhead cam design and 16 valves, it produced between 112 and 130 horsepower, depending on the variant. Its high revving nature and responsiveness made it a favorite among enthusiasts. One of the most iconic applications of the 4AGE was in the Toyota AE86, a lightweight rear-wheel drive coupe that gained fame in motorsports, particularly in drifting. The engine's balance and tunability allowed drivers to push the AE86 to its limits, earning it a cult following that persists today. Toyota's commitment to producing reliable diesel engines is further exemplified by the 1HDT and 1KDF-TV engines, both of which have been integral to the Land Cruiser's reputation for durability and off-road prowess. The 1HDT, introduced in the 1990s, is a 4.2-liter turbocharged inline-six diesel engine known for its robustness and torque. It became a popular choice for the Land Cruiser 80 series, providing the necessary power and reliability for both on-road and off-road adventures. The 1KDF-TV, a 3.0-liter turbocharged inline-4 diesel engine, succeeded the 1HDT in the 2000s. Equipped with Toyota's D4D Common Rail direct injection system, it offered improved fuel efficiency and performance. This engine powered models like the Land Cruiser Prado and Hilux, continuing Toyota's legacy of dependable diesel powertrains. However, as environmental concerns and fuel economy became increasingly important, Toyota shifted its focus toward developing engines that offered both performance and efficiency. This transition led to the introduction of technologies such as VVTi, variable valve timing with intelligence, and the D4S fuel injection system. Introduced in the late 1990s, VVTi technology allowed for continuous adjustment of the camshaft timing, optimizing engine performance across various RPM ranges. This system improved fuel efficiency, reduced emissions, and enhanced power output. Engines equipped with VVTi, such as the 1ZZFE and 2ZZGE, benefited from better throttle response and overall performance. The D4S system, introduced in the mid-2000s, combined direct and port fuel injection to optimize combustion. This dual injection system allowed for precise control of the air-fuel mixture, resulting in improved power delivery, fuel efficiency, and reduced emissions. Engines like the two GRFS EV6 utilize D4S technology to achieve a balance between performance and environmental responsibility. How Toyota pioneered hybrid technology. The birth of the Prius. Introduced to the Japanese market in December 1997, the Toyota Prius was a groundbreaking achievement. It seamlessly combined a 1.5-liter gasoline engine with an electric motor, creating a hybrid system that offered exceptional fuel efficiency and reduced emissions. This innovative approach allowed the Prius to achieve around twice the fuel efficiency of conventional gasoline-powered vehicles at the time, marking a significant leap forward in automotive technology. The Prius's design incorporated several advanced features to enhance its ecological performance. Notably, it utilized a regenerative braking system that converted kinetic energy into electrical energy during deceleration, storing it in the vehicle's battery for later use. This process not only improved fuel efficiency, but also extended the lifespan of the braking system. Additionally, the Prius employed an engine stop-start system, shutting off the engine when the vehicle was stationary to conserve fuel and reduce emissions. Central to the Prius's success was Toyota's Hybrid Synergy Drive, HSD system. This full hybrid technology allowed the vehicle to operate using the gasoline engine, the electric motor, or a combination of both, depending on driving conditions. The flexibility of HSD provided drivers with an optimal balance between performance and efficiency. The system featured a power split device, a planetary gear set that managed the distribution of power from the engine and electric motor to the wheels. This mechanism enabled the seamless transition between power sources, ensuring smooth acceleration and deceleration. Moreover, the system's design eliminated the need for a conventional transmission, reducing mechanical complexity and enhancing reliability. Another key component of the HSD was its battery technology. The Prius relied on a nickel metal hydride NiMH battery pack, chosen for its balance of energy density, durability, and safety. This battery worked in tandem with the electric motor to provide additional power during acceleration and to recapture energy during braking, contributing to the vehicle's overall efficiency. Following its initial success in Japan, Toyota introduced the Prius to the global market in 2000. The vehicle quickly gained popularity, especially in regions with stringent environmental regulations and fuel efficiency standards. Consumers were drawn to the Prius not only for its eco-friendly credentials, but also for its practicality and reliability. The company quickly expanded its hybrid lineup to include models such as the Camry Hybrid, Highlander Hybrid, and later the Corolla Hybrid. This diversification allowed Toyota to cater to a broader audience, solidifying its position as the global leader in hybrid vehicle sales. By 2013, Toyota had sold over 3 million Prius vehicles worldwide. While the automotive industry witnessed a growing interest in full electric vehicles, Toyota maintained a cautious approach toward this emerging technology. The company expressed skepticism about the immediate viability of pure EVs, citing concerns over battery technology, driving range, and the lack of charging infrastructure. Instead, Toyota focused on refining and promoting its hybrid technology, which it believed offered a more practical and immediate solution to reducing emissions and fuel consumption. Toyota's strategy was rooted in the belief that hybrids provided a balanced approach to environmental sustainability. By combining the reliability of internal combustion engines with the efficiency of electric motors, hybrids addressed the limitations associated with early EV technology. This pragmatic stance allowed Toyota to capitalize on existing infrastructure and consumer habits, facilitating a smoother transition toward greener transportation. Toyota's steadfast commitment to hybrid technology garnered both acclaim and criticism. Advocates praised the company for making fuel-efficient vehicles accessible to the masses and for its role in reducing automotive emissions on a global scale. The Prius, in particular, became a symbol of environmental consciousness, attracting a diverse customer base that included celebrities, environmentalists, and everyday drivers seeking economical transportation. However, some critics argued that Toyota's focus on hybrids detracted from the development and adoption of full EVs. As competitors began investing heavily in electric vehicle technology, questions arose about Toyota's long-term strategy and its potential to lag in the rapidly evolving EV market. Despite these critiques, Toyota continued to enhance its hybrid systems, achieving significant improvements in fuel efficiency, performance, and emissions reduction over successive generations. And while everyone is still talking about EVs, Toyota's CEO just made a shocking announcement that could destroy the entire industry. Toyota's resistance to full EVs, a calculated gamble. Unlike many automakers that have aggressively pursued EVs, Toyota has been cautious in its transition. The company emphasizes a multi-pathway strategy towards zero carbon emissions, which includes EVs, hybrids, hydrogen fuel cell vehicles, and other powertrain technologies. This approach reflects Toyota's belief that relying solely on EVs may not be the most sustainable or practical solution for all markets and consumers. One of Toyota's primary reservations about an all-EV future centers on the challenges associated with battery production. The manufacturing of lithium-ion batteries requires significant energy and involves the extraction of raw materials like lithium, cobalt, and nickel. These processes can have substantial environmental impacts, including habitat destruction and pollution. Additionally, the finite availability of these resources raises concerns about the long-term sustainability of large-scale battery production. Moreover, the cost of EV batteries remains high, contributing to the overall expense of electric vehicles. This financial barrier can deter consumers, especially in emerging markets where affordability is key. Toyota argues that without significant advancements in battery technology and reductions in production costs, mass adoption of EVs may be limited. Akio Toyoda, Toyota's chairman, has been vocal about his skepticism regarding the quick shift toward EVs. He cautions that an exclusive focus on electric vehicles could lead to unintended consequences, such as job losses in sectors related to traditional engine technologies. In October 2024, Akio emphasized that Japan's automotive industry employs around 5.5 million people, many of whom are involved in engine-related work. Transitioning entirely to EVs could jeopardize these jobs, affecting not only manufacturers but also a vast network of suppliers and associated businesses. Akio also questions the environmental benefits of EVs when considering the entire life cycle, including manufacturing and energy production. He suggests that a diversified approach, incorporating hybrids and hydrogen fuel cells alongside EVs, may offer a more balanced and sustainable path forward. In line with its diversified approach, Toyota has invested heavily in hydrogen fuel cell technology. The company introduced the Mirai, one of the first mass-produced hydrogen fuel cell vehicles, showcasing its commitment to exploring alternative energy sources. Hydrogen fuel cells offer several advantages, such as quick refueling times and longer driving ranges compared to some battery electric vehicles. They also emit only water vapor, making them environmentally friendly. However, the infrastructure for hydrogen refueling is still underdeveloped in many regions, posing a significant challenge to widespread adoption. Toyota's cautious stance has not been without criticism. Industry analysts and environmental groups have argued that the company risks falling behind as global markets increasingly embrace electric vehicles. Competitors are rapidly expanding their EV offerings, and consumer demand is shifting toward more sustainable transportation options. Despite this, Toyota remains steadfast in its strategy. The company continues to invest in hybrid technology and hydrogen fuel cells, aiming to provide a range of options to meet diverse consumer needs and regional requirements. But what if Toyota was playing the long game all along? What if they had something up their sleeve that could completely disrupt the EV industry? The science behind Toyota's engines. A potential revolution. The automotive industry is undergoing a massive transformation. The internal combustion engine, once the heart of mobility, is now being phased out by governments and manufacturers in favor of electric vehicles. But just as it seemed that gasoline and diesel engines were on the verge of extinction, Toyota emerged with a groundbreaking innovation. Recent reports and patent filings indicate that Toyota's next-generation combustion engine is unlike anything seen before. This isn't just an incremental improvement, it's a potential revolution in engine technology. In early 2024, leaked patents revealed that Toyota has developed a water-cooled hydrogen combustion engine designed to overcome one of the biggest challenges of hydrogen power: excessive heat. Unlike traditional gasoline engines, hydrogen combustion generates extremely high temperatures, which can lead to efficiency losses and durability issues. Toyota's new design solves this by incorporating water injection valves into the intake ports of each cylinder. These valves precisely control the amount and timing of water injection, ensuring optimal cooling and significantly improving engine efficiency. The electronic control unit monitors real-time data and adjusts the process dynamically, allowing the engine to operate smoothly under various conditions. If successful, this could mean a hydrogen-powered engine that offers all the benefits of traditional internal combustion: quick refueling, long range, and high performance, without the carbon emissions. But Toyota isn't stopping there. While the world debates whether electric vehicles are the ultimate solution, the company has been quietly making significant breakthroughs in battery technology. One of the most exciting developments is Toyota's work on solid-state batteries, a technology that has the potential to change the EV landscape entirely. Unlike conventional lithium-ion batteries which use liquid electrolytes, solid-state batteries replace this with a solid material. This simple change results in massive benefits. Solid-state batteries can store more energy in a smaller space, meaning vehicles can travel much longer distances on a single charge. They're also far safer, as they eliminate the risk of leaks and fires associated with liquid-based batteries. And perhaps most importantly, they can charge at an unprecedented speed. Toyota claims that their solid-state batteries could allow a full charge in just 10 minutes, eliminating one of the biggest drawbacks of current EV technology. In September 2024, Toyota's plan for next-generation battery production received certification from Japan's Ministry of Economy, Trade, and Industry. Production is set to begin in 2026, with an annual output goal of 9 gigawatt-hours. If these projections hold, Toyota could leap ahead of competitors in the battery race, delivering a product that makes current lithium-ion EVs look outdated. And the most surprising part? Toyota's solid-state battery development isn't just for electric cars. There's a growing theory that the company may integrate this technology with its hydrogen combustion engines, creating an entirely new category of ultra-efficient hybrid vehicles. The implications. Could Toyota render EVs obsolete? The implications of Toyota's next-gen engine technology are enormous. If hydrogen combustion engines can be perfected, they could completely eliminate one of the biggest drawbacks of EVs, charging time. Instead of waiting 30 minutes, an hour, or more for an electric car to charge, drivers could refuel their hydrogen-powered car in just a few minutes, just like they do with gasoline. The range could also be significantly longer than current EVs, making long-distance travel more practical. From an environmental perspective, hydrogen combustion engines produce only water vapor, meaning zero carbon emissions. But even beyond that, there's a crucial factor that few are discussing: the environmental cost of EV battery production. Mining the raw materials for lithium-ion batteries such as lithium, cobalt, and nickel is an energy-intensive and environmentally damaging process. Hydrogen and biofuel-powered engines could provide an alternative that bypasses these concerns entirely. With all these advancements, the automotive world is buzzing with theories. Is Toyota preparing to render traditional EVs obsolete before they even reach mass adoption? Industry experts are divided. Some believe that Toyota's multi-pathway approach, developing hydrogen combustion, hybrids, and solid-state EVs simultaneously, could make them the dominant force in the next generation of automobiles. Others argue that hydrogen infrastructure is still too underdeveloped to compete with EV charging networks, and that Toyota may be betting on a technology that's too far behind to catch up. But one thing is clear: while other manufacturers are scrambling to go fully electric, Toyota is proving that there's more than one way to achieve a carbon-neutral future. Their latest innovation could shake the very foundation of the EV market and challenge the assumption that electric vehicles are the only answer. The game changer. Toyota's CEO makes a bold declaration. And now, the wait is over. The game changer is here. In fact, Koji Sato, Toyota's CEO, just said, "Our new engine will destroy the entire EV industry. I've made my decision. We are putting it on the market by the end of 2026. But what makes this engine so special? According to insiders from Toyota, this next-generation powertrain is unlike anything currently on the market. The company has reportedly developed an ultra-efficient hydrogen combustion engine that significantly outperforms existing battery electric and hybrid technologies. Unlike traditional hydrogen fuel cell vehicles, which rely on converting hydrogen into electricity, this engine uses hydrogen directly as a combustion fuel. The result is a system that maintains the power and refueling speed of a gasoline engine while producing near-zero emissions. Toyota engineers have reportedly integrated advanced cooling and injection technologies that solve the high-temperature issues typically associated with hydrogen combustion. By utilizing a precise water injection system and proprietary ignition technology, this engine not only eliminates harmful carbon emissions, but also achieves efficiency levels previously thought impossible for internal combustion engines. Industry analysts suggest that Toyota's breakthrough could reshape the automotive landscape. With concerns over EV battery production, resource mining, and charging infrastructure still unresolved, a hydrogen-powered alternative offers a compelling solution. Hydrogen refueling infrastructure, while still in development, has the potential to expand more rapidly than mass EV charging networks, making this a viable long-term competitor to battery electric vehicles.